Good day and welcome to A-Level with Elmini Wilson. I do believe that today is a good day to understand maths better. This session today will be on functions. This was a result of an Instagram poll that I took or that I posted, and most people voted for functions. It was functions against calculus, and then functions won. So we're doing that today. Not a lot of people are fond of this topic, so it is one that we need to battle through together. Good news is in the word functions, there is the word FUN, so fun is in there. We just need to find it. Okay, so what I'm going to start with today is just basically explaining to you what does it mean to be a function. Just a few things before we start. I would like you to have the right tools. So I would like to have a calculator close by. Can you use the FX911ZA+2, as well as just a quiet environment, positive headspace, some stationery. We won't be using the formula sheet that much today, but it's nice to have everything close by, just in case. Okay, let's dive into functions. So for functions, let's first start with the definition of a function. If you consider, let's say, a sine graph, let's start with a horrible one. If you look at a sine graph, I am going to tell you sine graph is a function. But how do I determine that? And let me show you something that's not a function, like a square root graph, something that looks like this. Y is equal to plus minus square root x. This is not a function. So what is different? What can we use as a measurement of when something is a function? I like to use just a random pencil, okay? And I move it across my sketch. If it only touches once, then it is a function. So this is called the vertical line test. So basically moving it across, the first sine graph actually does work. So this is a function. But this is not a function because if I move my pencil across here, I will be touching twice. Okay, some things that you need to know is this is also called a many-to-one function. Many-to-one. What that refers to, let me just show you what I'm writing. What that refers to is many x's for one y. So that's happening here, like there's an x and there's an x, but they all relate to one y. And that's still fine. Many to one is still fine for a function. But the second one is called a one to many. And that's not okay. So 1x for many y's, basically what happens is you fail the vertical line test. So this is not a function. Okay, so what can happen? I just want to show you, these are the first two types, one to many and many to one. This one, just remember, it refers to one x, like here, many y's. So for instance, x equals to 1, but then you have many y's matching with that. I just want to show you some other examples. There's two more. I want to show you a many to many. I'll do them next to each other. A many to many would be like a circle. Many x's, many y's. Okay, so if you're making notes, just make some notes here. This is many to many. Just by the way, a many to many will not be a function. Okay, so not a function. And then let's just do something like a straight line. A straight line will be one to one. 1x, 1y, and it is a function. Okay, just something important. I know we were speaking about the square root graph a little earlier. We were speaking about this one. I do need you to know that a square root graph is actually the inverse. We're going to do inverses just now, but that is the inverse of a parabola. So a parabola looks like that. Y is equal to x squared, or it can be more complicated, but y is equal to x squared is traditionally classified as, maybe you can tell me, this is going to be the same as a sine graph, many to one. But then the problem is if you do the inverse, let me just sketch the inverse. Suddenly the inverse is not a function because this is the square root graph, not a function. So what I'm going to teach you later is how to make a many to one, which it is currently. How can we make it a one to one? The easiest way is chopping off a leg. So for instance, if I restrict my domain here and I say, hey, x has to be bigger than naught or including, that means you lose your negative leg. So then later, when you do your inverse, you'll also lose your negative leg. And then your black one on its own is a function that's 1-to-1. And also the red one, the inverse, is also a function 1-to-1. So that's the first part I wanted to talk about, is the 4 types. So let's just recap. There's many-to-one, 1-to-1, many-to-many, and 1-to-many. But only 2 of them are functions. Okay. Lots of information already. If you want to pause and just take a breather, go make some coffee, that's also fine. We'll do this section by section. The next part I want to talk about is starting to mess with inverses and compounds and then transformations. We're going to tackle everything today. So that's why I'm saying let's take it step by step. Next subsection of functions is inverses. So if you want to write something down, inverses. Inverses. Okay, subheading inverses. Let's just get the notation right first of all. Let's take a normal f of x and then let's say x minus 3. Let's keep it easy for now. It's nice and linear, 1-to-1. And then let's quickly do the inverse. Now the inverses notation, they'll probably ask you for f minus 1x. Please, with exam stress, this might start looking like derivative. It's not the same, hey? Just want to make sure you understand. Inverse, derivative. So not the same thing. Then, note for yourself, this is inverse and this is derivative. Major difference. So please don't get confused. For inverse, I just want to give it like a recipe. So for inverse, we do 2 steps, always the same, always 2 steps. The first step is to transpose. Now that's the fancy word, transpose x and y, but that just basically means you swap them. And then your second step is to make y the subject. So that's basically what we're dealing with. Transposing x and y is nice and easy. Check if I see a y there, you know f of x is y. You see an x there, you just swap them, or transpose if you prefer that. And then you try and make y the subject. So in other words, get y alone. So x plus 3 is equal to y. So the nice way of writing this then is the inverse is equal to x plus 3. And that's how you do inverse. As easy as that. Also important to notice is when you have to sketch this was the intercepts will be minus 3 and 3. And then if you sketch the other one, the coordinates that you have here will just swap. So everything that you're doing is going to swap. So if your x here was negative 3, or your y, then your x becomes negative 3. If your x here was 3, then your y will become 3. So then you just sketch that one as well. You'll see, interestingly enough, that whenever you sketch it, it will reflect over the line y equals x. Always. It will always reflect over there. Sometimes it even cuts. It won't always have to be parallel like it is now, but it will always reflect over that line. So that's important to notice for inverses, that you swap x and y. First step, swap x and y, and then get y alone. Straight lines, not as popular to find the inverse of a straight line. They more often will ask you to do the inverse of a parabola. So if we do the inverse of a parabola, let me just help you with that. It has to be in a certain form. It has to be in the completed square form. And that also sometimes be a question on its own. First complete the square and then get the inverse. Okay, so let's do that together. I do minus y squared plus 6x minus 5. If you write that down, I just want you to notice that it's not in completed square form. That is obviously still in standard form, A, B, and C. So if I ask you to write it in this form, I'm basically asking you to complete the square. Okay, so I'm asking you to complete the square if I ask you to write it in this form. Or I could have just asked you straight away, find the inverse. Now, in order to find the inverse, you have to have it in completed square form. Long way and then with a shortcut. The long way to complete the square, please remember to always take out the coefficient of x squared as a common factor. That would be your first step. Because if you don't do that, everything else after this will be wrong. So very important first step, common factor there. And then what I normally do is I put an x in a block here, because later when we do circles, you're going to have to do an x and a y in the same step. So I do an x to remind me coefficient of x. You always say half times coefficient of x squared. And then you actually do it. And you have 3 steps on the side here, because that's going to help you to complete the square. Everything happens inside this bracket. You do your last step first. So you plus 9 and you minus 9, because you're not allowed to change the value of your expression. So then you have that. And then I'll show you, you will be creating a square bracket with some other numbers here. But remember, the minus will always be in front of the full expression. So these square brackets are super important. Inside your square bracket, you will have your middle step, which is minus 3. And then you will have what is left over. The first 3 actually made your square bracket. So what's left over? I've actually got a minus 4. So then your final step will be x minus 3 squared with a minus in front, and then plus 4 when you distribute the negative in. That was the long way. If you're ready for a shortcut, I know you guys always like shortcuts. Let me help you just with how to use this calculator. First things first, you go to mode, check for equations EQN 5. This is a trinomial, so you pick number 3, and then you type in your coefficients from the first step. Minus 1, 6, minus 5. Okay. Minus 1, 6, minus 5. This will give you the x-intercepts. We're not really interested in that at the moment. But the last part, the x value maximum, that's very important. It is a maximum because it's obviously a negative parabola. But let me show you what I'm comparing that 3 to. That 3 is this minus 3. Because when you actually sketch the parabola, it's going to look like this. And the coordinates of your turning point will be 3 and, let's get the other answer from the calculator. The y value, I get a 4. Y value maximum 4, y value maximum 4. So whether you do the long way or the shortcut doesn't matter, because in the memo, the marks are allocated like this. Sometimes even for this minus 1, you will get a mark. The problem is the calculator won't tell you about that minus. You will have to check coefficient of x squared is the value of a. Just copy and paste. Let's make it darker. Copy and paste, just like that. Also, yeah, remember the sign did change when I use my bracket here. That is important. And then you have your little parabola. So now after that, I can ask you questions like, find the inverse. There is a little bit of a problem with my inverse, because I said earlier, if you have a many to one parabola, you can't actually find the inverse. They say the inverse doesn't exist because the inverse is not a function. So you need to chop a leg off, either this leg or this leg. Sometimes the question will guide you and they will tell you for what is the largest value for which you can have an inverse. And then I could have maybe something like this. X smaller than equal to k. See, that is a domain restriction. So when you do a domain restriction and you look at your parabola, for instance, I would love to say that x will have to be smaller than equal to 3. So in other words, if k is equal to 3, what will happen? Let me just show you with my red pen. I'm chopping off a leg. X must be smaller than 3, so it can't be bigger than 3, so I'm losing that whole side. But the good news is then you have a one-to-one function, and then when you inverse this, it will have an inverse, and the inverse will also be a function. Okay, I hope I haven't lost you yet. I just want to make sure what we've done has gone in now. Completing the square is the first step of getting the inverse. And the first step of completing the square is taking out a common factor. If you don't do those 2 steps, everything else is wrong. So I hope that that went in. If you need to just listen to that again, just go back 20 seconds and listen to that again. Make sure it goes into long-term memory, because long-term memory, even with stress, you will be able to access it. Sometimes short-term memory gets muddled, but long-term memory is fixed. So if hopefully by doing it over and over and over again, even your exam stress won't be able to erase that or muddle it. I am happy to do just like one more question relating to this. I did ask you for the inverse. So I would love to do the inverse and then ask you the domain and range for the inverse, because we haven't spoken about that yet. So for my original, just notice my domain is x smaller than 3. Can we quickly talk about your range? If your x must be smaller than 3, what does your y look like? The y looks like it's going smaller than 4 then. If you had a different value here, like let's say it was maybe 2 or 1, you just get your y value by subbing it back into the original, and then you have your range. So this is for your normal f of x, domain and range. It is very important to actually sketch it, because otherwise you wouldn't know what's going to happen. If like your x is this, what is your y? It's very nice to just sketch a parabola. And then when you have your original f of x, I'll show you how easy it is to get the inverse. Inverse of f of x is y. The x and the y will swap. So your x must be smaller than 3. So now your y is going to be smaller than 3. Your y used to be smaller than 4. Now your x needs to be smaller than 4. You see how easy that was? So please remember to just swap the two, x and y, transpose them. But we haven't actually found the inverse yet. So I've been talking a lot of things, but I haven't actually done what I'm supposed to do. And that is finding the inverse. So I'm going to use this one. I've said this now a few times. Hopefully that sticks. That you have to have it in this form. Otherwise you can't find the inverse. Okay, completed square form. Let's swap x and y. So this is x and this is y. So we're transposing x and y, and then you try and get y alone. It's only 2 steps. This recipe can't fail. So I'm gonna maybe bring the 4 over, and then I still have a negative here. Just follow with me. I'm going to times everything with a negative. So it's going to be negative x plus 4, y minus 3 squared. Very important to square root. Square root. When I square root, the square will go away. Also very important at this stage, plus minus. Don't forget to put the plus minus there. And then you get y completely alone. I'm going to say plus minus. We're going to have to make a decision here, because I remember there was a domain restriction. And this is y minus 3. Because remember, square root and a square will cancel out. So my final answer for inverse is, okay, now I just need to decide. The 3 is obviously going to come over. So there's going to be a 3 and then the square root. But I need to decide, is it going to be positive or is it going to be negative? Square root minus x plus 4. Which one? Positive or negative? We've got 2 options. Remember that we had a domain restriction here. There was a domain restriction for the original, which means that there's a range restriction for the inverse. We are sticking to the negatives here. X had to be smaller than 3, which makes you have y being negative 3 or smaller than 3. So that means you are left with the negative leg. So you are left with negative. Let me just make that very clear. It needs to be negative, and that is your inverse. Inverse with domain and range is a very popular topic. So inverses obviously can become a little bit more difficult if they start changing your domain. Remember, if you change your domain, your range will follow suit. You can't just mess with your domain and your range will stay the same. The easiest way to see what the domain does to your range is just to sub it into your equation. Okay, so that was inverses, sorted subsection of functions. We just need to do 2 more subsections, and that is compound functions and then transformations. Okay, so the first thing I want to do now is, can you write down compound functions? Compound. Compound or composite. You can actually use both words, compound or composite. That's basically a function of a function. The actual algebra is very easy. It's just like subbing the one into the other. But sometimes the domain and range get to people here. So important to obviously know what you're doing, first of all, with the algebra. But more importantly, knowing the theory behind domain and range. Remember, for inverse, domain and range just swaps. Don't get confused there. It's only with this composite functions where it gets like nitty gritty. So compound or composite functions, let me just show you the notation. Sometimes they can give you like an f of x and a g of x. I'm just going to make it very easy to start with, something like that. So you can do things like f of g of x. We'll do that. We'll also do a g of f of x. And then I want to show you, we can even do an f of x. Okay, I know some textbooks print it like this with like a little thingy there in the middle. That means the same thing, hey? Composite or compound. So what I'll do for f of g of x, that just means in your f where you see an x, you sub g of x. So it's going to look like this: x minus 1 squared plus 2. Easy, right? And then you can simplify it. Hey, you'll square this. But just notice again what I did. I subbed this one's g of x into the x of f of x. That's what they're saying. They say take this and sub it in there. That's an important concept later when we talk about domain and range, to notice what's happening. The y is going into the x. So this domain must be ready to receive this one's range. Okay, that's going to be important later. Let's do g of f of x. That just means inside your g's x, you sub f of x. So I'm going to say x squared plus 2 into there. You can use a bracket if you want, minus 1. And then simplify. Let's try this one. F into himself would just be, remember, bracket usage are your friends. Even if there was like more x's, you'd have to sub it into every single x. So you sub f of x, which is this, into himself. So that's into himself. I hope that makes sense. That is basically what you do for composite functions. They can obviously be variables later. They can put like an a or a b here, and then they can tell you f of g of x is 17. Then it will be a lot of algebra. But yeah, that's basically all I want you to know about the composite functions, how to get to a composite function. Then I want to quickly chat to you about how to get the domain and range. So let's try this one. Let's try f of g of x that we were speaking about first, f of g of x. If you want to find the relationship between the two, I feel like this little diagram that I'm going to draw, we always call it Sid the Sloth, like a little diagram where it looks like my sketching skills. Like a little alien, hey? This is the best way that I can explain this to you. Little Sid the Sloth, if you've ever watched Ice Age. What basically needs to happen is if you have a domain of G, so your domain of G, into f of g of x. I will later show you how to do that. But if you sub the domain of g into f of g of x, you will get to the range of f of g of x. Okay, so there's one direct route to get from domain of g directly into the range of f of g. You can also go like this middle route, the domain of g. If you sub the domain of g into the g graph, you will get the range of g. But then just remember, this range of g needs to be contained within the domain of f. And that's what I originally tried to explain to you here. The g of x, the y part of g, the range of g, is going into the x of f of x. So this x better be ready to receive the y's. So that's what I'm saying here. The domain of f needs to be ready to receive the range of g. It needs to be contained within. So yeah, that's one route. And then if you want to get from here, if you have your range of g and you want to get to the range of f of g, you can just sub that then into f. So this Sid the Sloth, you can quickly copy this down. Maybe you can make it nicer than I did. This is specifically for the compound function f of g of x. There's a direct route, and I will be referring back to this again, or you can go this route, but both of them will give you the range of f of g, and they love asking for the range of f of g. Whereas the actual getting of f of g of x, that was easy. But now if they're going to start messing with like this domain and this range, and that's going to affect this one, it's important to have Sid the Sloth close by. I'm going to give you f of x, and I'm going to make it more difficult. I'm going to give you maybe like a fraction. So let's make it 2 over x minus 1. And then I'm going to give you a domain restriction. I'm going to say x must be bigger than 1. Okay, so that's obviously going to affect your range, but let's just discuss that a bit later. Your g of x, let's make the g of x maybe like a parabola. And then when we do the compound, I'm going to ask you for domain and range. So that's going to be tricky. So the parabola I want you to use, let's use x squared minus 4x, it's like plus 7. And then let's make him x smaller than 1. So we have some domain restriction, which makes it difficult. And then I'm going to ask you to first find me the compound. So I want you to find me f of g of x, f of g of x, just like we did above. Hey, that's going to be related. We're going to use Sid the Sloth definitely in this question. But let's just do the easy part. The easy part was finding f of g of x. So that means wherever you see an x in f of x, I want you to sub in, even if it's this whole thing, you please sub that in. So it's going to be 2 over, and then instead of saying an x, I'm going to say x squared minus 4x plus 7, because I'm subbing my g of x, my y part, into the x of f of x. And then don't forget minus 1, because you need to still remember what f of x was. This was f of x. Though that x is the only thing that gets replaced. You can simplify a little bit, but this wouldn't be the part that gives you the most marks. The part that comes now will be the most marks. I can ask you after doing that, well done, but now get the range. So getting the range of, let's just do the range for this one. The range of f of g of x. There will be 2 methods to do this. Remember I said earlier, you can take the domain of g, sub it into the one that you just created, and that is a direct route into f of g of x's range. So let's do that first. So we need the domain of g. Here's domain of g, x must be smaller than 1. So if I just observe what's going to happen, when x is smaller than 1, this is f of g of x. So let's call this f of g of x, f of g of x. We need to observe what happens to f of g of x when x is, what was the domain? Smaller than 1. So let's first see what happens if x is maybe exactly 1. Let's sub a 1 in here and see what happens. Okay, so you've got your calculator. I want to see what is f of g of 1, because that is going to help us determine what the range of f of g of x is going to be. So I'm typing in 2 over 1 squared minus 4 times 1, and then plus 6. Okay, so I get 2 over 3. Very, very nice. But now I need to observe what's going to happen when x becomes smaller than 1. So smaller and smaller and smaller and smaller than 1. Let's take something ridiculously small like f of g of, I almost want to say negative infinity. But maybe like negative 1 million. I just want to see where are we heading. If you've watched some of my previous videos, you'll probably know what's going to happen, because if you have a finite numerator with an infinite denominator, I remember if I want to sub in infinity, this is going to approach 0 basically. But if you're not comfortable with infinity, that's fine. Sub in negative a million into everything that you did last time, where you subbed in the 1. Now you sub in negative a million. Okay, so I'm thinking this is going to be quite big in the denominator. But if you have a very, very big denominator, just consider having like a pizza and you get 1 piece out of a million of that pizza. It's going to be super, super, super small. I actually just want to quickly explain. Definition of infinity in a fraction is if you have a finite numerator, so the top is a 2, but your bottom is like a million, million, million. Consider, I always like using the pizza analogy, you get 1 sliver of a pizza that's divided into a million, million, million. That's very small. Hey, they say insignificantly small. So I do want you to notice that if you sub in something really big in the denominator, it's going to approach 0. And that's exactly what's happening here. You will tend to 0. Okay. So then if you want your range, you can go y must be bigger than 0, smaller than 2 over 3. I think that's the easiest method there. But if you want to do the other way, is another way. Let me just discuss it with you. You take your domain of G. So you take the domain of G and you sub it into G to get the range of G. Then you take the range of G and you sub it into F, and then you get the range of f of g of x. I do feel like this is a quick and easy way. I would prefer you to do it this way. But it's nice to remember some of the other questions can relate to how big must f of x be to accommodate g. And that's when I want you to think of what I said here. G, the range of G must fit into the domain of F. I hope all of this is making sense, because I've seen with my students, this is normally where they lose the plot. But I think Sid the Sloth might help you. Going through plenty of past papers also might help you. If you find an interesting one, send it through, I'll do it for you. Okay. Last section, this feels like almost a whole past paper that we're doing. Last section, we're doing transformations. Okay, so transformations, not difficult, just a lot of studying. Sit and study. That's what I want you to do. There's only like a few groups that we need to discuss, and then how they can possibly ask it in the exam. Okay, so if you want subheading, transformations. Okay, transformations. Let's quickly discuss the different groups of transformations. The first one that I would love to do is a transformation. Oh, translation, there you go. I've seen in the papers that I've marked, people classify a transformation as a transformation, and that's not correct. There's a specific type. A translation is a type of transformation. And that's if you, for instance, if you take a graph, let's say f of x, you don't even need to know what f of x was. And if you start moving it, so if you go f x minus 1 plus 7, that's a translation. You've moved it. Just remember, if it's in a bracket with the x, it's always the opposite. So this would be a translation through a vector 1 and 7. Or you can even just say it's a translation or a shift 1 to the right. Remember, this is 1 to the right. Even if it says minus 1, you say 1 to the right and 7 up. Translation, perfect. The next type that you could have is a stretch. So a one-way stretch or a stretch. That is if you start messing with your f of x, like in front of your f of x. So this specific one is a one-way stretch, and it's affecting your y. So you can say parallel to the y-axis. And then your scale factor is important. Your scale factor will be very regular. For y, it's never weird. For scale factor 2. So if they say times by 2, you just say times by 2, times the whole equation by 2. And that is a one-way stretch. But you do get 2 types. So here's my one-way stretch. But you can also get a one-way stretch that looks like this. Now your x is being affected. So please say one-way stretch parallel to the x-axis. But now the scale factor is different. This will be scale factor. Try and solve this. Let's say it was like 2x equals a. X equals a over 2. Do you see that you actually try and solve for x? So this will be scale factor a half. Okay, that was very important to notice that even if it was like 3, it would be 1 over 3. Or if it was a half, you'd have to keep flipping it if it's with your x. So far we've got translation, we've got a stretch, and then we just quickly need to discuss reflections. Okay, so there's three main types. The next one is a reflection. So a reflection would either look like this, negative f of x, that's your one type, or f negative x. But now you also need to be very sharp here. I try and draw a little Cartesian plane and just orientate myself. If I take the coordinate 2 and 3, and I want to change my y to become negative, do you see I will be here, 2 and negative 3. So that's very important where this new coordinate is. It looks like I was reflecting this over the y-axis. Okay, so, ooh, wait. I did that wrong. See, I'm just proving I'm not an AI, okay? If I change my y, it will actually go here, meaning. So it will be 2 and negative 3, because the 2's stayed the same and only the y changed. So over which axis did I actually reflect? I reflected over the x-axis. So that's important. If you change your y coordinate, I hope I didn't confuse you there, you're reflecting over the x-axis. Then I can do this one where your x actually changes. So don't get confused. If you have 2 and 3, you change your x coordinate, then you will come here. But then do you see over which axis did I hop? I hopped over the y-axis. So there's 2 reflections, reflection in x-axis, reflection in y-axis. It's not very, very difficult to just quickly remember those 3 types, but I want to show you how they can ask it. They can even combine this with tree graphs, and then you need to be quite sharp. Okay, so here's a nice example. Like if I give you just a normal sine x, and I ask you to do stuff to sine x. Let's say this was f of x. Then I ask you maybe to do fx minus 30 plus 7. So how do I apply this here? You can apply it by just going into the x. So x minus 30 plus 7. And then obviously if you had to sketch it, this would mean it's a 30-degree translation to the right. I know the minus is there, but you go to the right and then 7 units up. Remember, this will also affect your range. Normally a sine goes up 1 and down -1, up 1, down -1 because of the amplitude being 1. But now if you move it 7, you need to move the top and the bottom by 7 up. So that could affect your range if they ask you for range. Let's stick with y is equal to sine x. If I ask you to do maybe a 2fx, all that would do is you'll times the whole graph by 2. So you'll say y is equal to 2 sine x. So that's also a stretch, and what will basically happen is you'll go up 2 and down -2. So that's bigger than a normal sine graph. Obviously, if I start messing with the x, that's going to be quite interesting. Like if I say y is equal to, or let me do it first like this, if 3x, that's going to become sine 3x. Do you see whatever they do, even if it was a parabola or whatever, you just sub this into wherever the x was. And this is actually messing with your period. A normal sine graph has got a period of 360 degrees, 360. But what this 3 means is actually you need to make 3 waves in 360. So you'll make like 1, 2, 3 waves in 360. So your period will actually be 120. Do you see that I'm actually shrinking it then? I'm making, it's going to be smaller when I do so. This is going to become, you know, scale factor 1/3 if it is a one-way stretch, because you're shrinking it. Okay, so period of 120, then if you do that to your sine graph, then obviously reflections you can also do. Just remember, if they say reflection in the x-axis, if you go back here, reflection in the x-axis, you make y equal to negative. And then a reflection in the y-axis, you make x equal to a negative. Okay, so that doesn't normally really happen with a sine graph, but it does happen with parabolas and other functions that you might consider. I think that is basically me for today. It was fun, I hope. It was tough. And I do feel like this is a video that you might have to watch over and over again, maybe every time before you write, just to refresh. Please let me know if there's any questions that pop up, new questions that I can do with you, and I would love to help you in that way. So please subscribe to my channel so I can keep making videos for you, and maths is the future. Yes.